All right, guys. Well, welcome to my presentation here. Going to be going over a number of stuff that's new in GibbsCAM 2023, but there's actually a lot of stuff in GibbsCAM 2023, and I think Mike mentioned this, but we just don't have enough time to go over everything in detail. So we have some YouTube videos that will be up shortly, and you can watch those in detail. But this is just meant to be a something to whet your appetite here. So the first thing I want to talk about is prime turning. I think it's probably the big new exciting thing that we have in GibbsCAM 2023. So I'm going to play a video here and talk a little bit about it, and then I'll jump into the GibbsCAM demonstration here. So prime turning is a new type of turning that uses specialized tools to achieve vastly improved cut times and minimize tool wear. Prime turning offers the flexibility to turn in all directions, delivering a productivity increase of more than 50% in many existing turning operations. It also allows you to apply higher feeds and speeds compared to any conventional turning operation while still maintaining the same close tolerances and chip control. At the same time, prime turning provides substantially higher tool life. If you're not familiar with prime turning, I recommend you talk to some of the Sandvik guys here, but you can kind of see how it destructs the chips like this. That's a big thing. You don't have to worry about it wrapping around your part or anything like that. We're also taking pretty hefty cuts. And I think the video shows it, but we have a bidirectional cuts on both types of tools. So we have two types of tools here. This is the prime A here, and that's the prime B. And I'll talk more about those here in a little bit when I jump into my demonstration. But yeah, I'm really excited that prime turning is coming to GibbsCAM. So let's jump into the GibbsCAM side of this. So this is a part I want to demonstrate. First thing I'd like to do is kind of show you guys the tools. So when you jump into your tool menu here, we have two new types of tools, prime A here and prime B. This is a prime A down here. And while it can take deep cuts, it's mostly meant for, maybe your finishing passes or lighter cuts. You can actually, I believe you can use each one of these three sides of the tool. It rotates in the holder, so you're getting a lot of longevity out of this tool here. And then the other one here is the prime B. This is what this guy looks like. This is more your workhorse. This is what we're going to be using to, rough out our part and take as deep cuts as possible here. So let me show you how to make operations with these. So I'm going to start off with the facing operation here, and it's not really a deep cut, so I'm going to use my prime A insert for this. Probably both would work. And then down here in the turning section, we have a new process type called prime turning. Now, this is the only type of process you want to use with the prime A or prime B tools. The tools are specifically made to work with this operation type and these kind of motions. So it's important that you only select prime turn when you're using prime turning tools. And likewise, you don't want to use any normal tools with this prime turning process either. Okay, so the first thing you want to do is fill out one of these four boxes here. So this is going to be a front face operation because it's facing operation, and this is a metric example, so that's why my numbers are so high here. I'm not going to bother leaving any stock, and I'll talk about most of this stuff a little later, but those of you who are familiar with GibbsCAM processes know that there's really nothing new here. Everything I'm doing is how I would set up a normal facing operation. I'm going to start off my stock above, go below the midpoint, and generate it. So that's how easy it is to make a facing operation. Let's do something a little bit more substantial. So I'm going to do some OD roughing next here. So I'm going to be using my prime B insert. This is the big one. Again, I'm selecting my prime turn, and this is going to be an OD operation here. And the next thing I want to do is I'm going to make this a roughing operation instead of a finishing, and adjust my clearance planes. So Depending on which type of tool you're using and how deep your cuts are, it gives some recommended cut depths here. So it's calculating that based off of a couple things I have set up here, but it's saying anywhere between 0.5 millimeter and 3 millimeters is the recommended cut. So I'm gonna be somewhat aggressive here, and I'll go almost to the limit here, 2.75 millimeters. And let's leave just a little bit of stock so we have something to clean up later. Your feeds and speeds are down here. Now, I know normally in GibbsCAM we have these little boxes that you click to update your feeds and speeds, but prime turning involves, very specific RPMs and surface feet per minute. So I recommend you look those up for each operation that you're doing, but in this case, I'm going to stick with these values here. So once you've filled out your box, you just select where you're cutting, just like any other operation. I'm going to start right here at the top. And like I said before, with prime turning, it's bi-directional. So I could go either way. I could start here, I could start here. But just to exemplify that I can go either way, I'm going to go backwards like this. And even sometimes within a toolpath, you'll see it go forward and then backward on the next cut. So I'm not sure if we'll see that here, but I'll hit do it. So this is kind of what the toolpath looks like. Pretty deep cuts. It should go back and forth usually. And even though the toolpath itself looks kind of long, there's a lot of moves, it's actually going at a much higher feed rate, so we're saving a lot of time here by doing this kind of toolpath. I'm going to simulate everything at the end. I'm going to make one more toolpath here with my prime A. And this one will be a finishing pass on the OD. Not going to leave any stock. All right, and then I'm just going to set up my markers. All right, so as you can see, if you're familiar with turning in GibbsCAM, you're probably already familiar with how to do prime turning. Let's look at this on a machine. We got our Hyundai Wia 2200 LSY. Get a good view here. All right. So yeah, that's about it. Pretty easy to use. If you guys have any questions on prime turning, I recommend you can either talk to us or the Sandvik guys. They probably know a little bit more about it. I'm personally new to this too, so but it seems pretty straightforward. I'm going to go on to my next topic now. I have something about part organization and ease of use in GibbsCAM and the things that we've updated here. Let it load for a sec. Okay, so I got a relatively simple part here. I'm just using it to demonstrate some of these new features. The big new one that I know a lot of people will like is we can now sort our coordinate systems and work groups into categories here. So if I jump over to my coordinate system list, I have 4 coordinate systems. This part was programmed to the bottom of the rotation of the machine here, but I also have a top plane. But now I can click here, new category, and I can sort these into categories. So I'm going to make a folder that kind of makes sense. And then it's easy to just click and drag the relevant coordinate systems into this folder here. And I'll go ahead and create another one just for my other one. So I know, and then we can, I can show all of these, I can hide all of them. So it's got like a little red cross here at the bottom for each one of these if I want, and I can collapse these. So a lot of people have been asking for this. I also have some work groups here. So, if I turn on my geometry, I used a point there for a hole, and then I use this for some stock creation and other things. So pretty cool. I'm excited about that too. The next thing I want to show is something called work areas in the document control dialog box. Now, this is actually something that we could do before in GibbsCAM, but you had to contact the post department or your reseller and ask them, hey, I need to update my MDD, and then they'd have to change it and get back to you. Now they've thrown this functionality into the user's hands, so hopefully reducing the need to, contact everybody. Let's go into my machine sim here, and I just want to kind of show the problem that I'm having with this operation here. So the operation itself is fine, but the trunnion's tilting backwards, so not only can I not see it as a programmer, but the operator is not going to be able to see what it's cutting and everything, and in general, it sounds like people like it to tilt forward. So now what we can do is go into our document control dialog box here, and we have a new section called work areas. Now this will only show up if you have a machine with 2 rotary axes. So in general, that's a 5-axis machine. I'm going to click new work area and kind of just give it a name. And so now my second rotary axis is my A axis here, so I can check these on and I can tell it, hey, I need you to stay between 0 degrees and 120 degrees rather than it going from 0 to -20 as it was before. Once I've set this up, I can close this, and then I'm free to apply that to any operation that I want. So I'm going to apply it here by going to operation data, and any work area that I've defined should show up here. So I'm going to select the one I just created. And I actually don't even have to regenerate my operation. My operation is going to stay exactly the same as it was, except all the A minuses are going to be positives here. So I think that's nice. You could also do it with the C-axis, or if you have a like an MTM with a couple like a B-axis or something like that, you can still utilize this in that way as well. So pretty good stuff. The last thing I want to show you on really the big thing that's new in GibbsCAM 2023 is you might have noticed that I have 3 operations here, but every time I went into Machine Sim, it was only playing 1, right? That's because I have these first 2 operations deactivated. So they're still here, but you can tell they're deactivated by the kind of darker gray background here. And it's easy for me to just activate them like this, but the purpose of deactivating and activating operations is if I want to experiment with maybe programming a part 2 different ways, and I want to use tooling, certain tooling on my first try and certain tooling on my second try, or I want to compare run times, I could do both of those operations here in GibbsCAM and then compare them separately on an op sheet to see how long each one took, that kind of thing. And before, if I was using any kind of material only option in one of my processes, it would think that there's no material there because I already have operations. So now we can just deactivate them and pretend that they're not there. So those are the big things in terms of ease of use of GibbsCAM 2023. I'm going to move on to some milling stuff here. All right, so I think this one's a big deal too. It's if you ever done any kind of use live tooling on a MTM machine to make a channel or anything that's not in the XZ plane here, it can be kind of cumbersome. So if you're not familiar, what you have to do is you have to select your face, you have to extract the geometry, right? And then that'll extract it along the circle here. the cylinder, but then you have to unwrap it, right? So GibbsCAM makes it flat with unwrapped, and you get something like this. I had to manipulate this geometry a little bit, so I had to connect a few things. I had to make these lines here so that it's a closed profile, and then I had to make these walls so that GibbsCAM knows that there's no solid there, and then it can break free and kind of do what it needs to do. And so there's a lot of steps. I want to say, 5 or 6 steps. It can take 10 minutes per channel that you're doing. So we added something new here. So we can just skip the geometry altogether. So most of you should be familiar with the slice planes. They're usually, use your coordinate system to cut your part and get shapes. We now have a cylindrical one here. So when I turn it on, it comes on in my active coordinate system. That's not the one I want to use it in, so I'm going to switch my coordinate system to an XY plane here. And then I can kind of click and drag to make this the size that I need. Right, and it's just a shape getter. You see when I intersect the solid, it brings up these little gray or green lines, right? I'm going to put it at a depth that I know is going to get the exact shape that I want. But now, so all I have to do now is just select these sides and hit do it, and it'll make my operation right away. So there's no geometry involved, nothing like that. As soon as I'm done, I can just turn it right back off. There's really no difference in how you set up the processes or anything. So that's a big time saver for people who do a lot of MTM work. And in case you're wondering, it does actually work in VoluMill as well. So because VoluMill is made by a third party, Solarative Technologies, the process acts a little bit different when we do it. So we have a lot of maneuvering and stuff like that because this operation was generated off of a 2D flat unwrapped geometry rather. So but now I can just turn this on, select my my bounding geometry here, and hit redo. And you see there's a lot less maneuvering. We have one entry point. So let's take a look at these operations. I'll do the first one first. So another thing here, it's plunging right in, which may or may not be okay. So that's the original operation, and then let me show you the other one. And in true VoluMill fashion, it makes a slot and then goes out of the slot. So that's a big time saver for anybody who's using MTM. Right, one more thing in milling that I'd like to show you. All right, so this is another really simple one, but a big one in my book. So I want to rough my whole part, the outside of my part, but it always keeps plunging in here. So all I did was, select the tool I want, select my entire part, and hit do it on a roughing operation. And it's entering from the sides and stuff like I like on the outside, but it's still trying to plunge down into these holes, these cavities, all this kind of stuff. Anywhere the tool is going to fit, it's going to try and get in. And I want to do those features with different tooling, different methods, using a drill maybe for some of these holes. I don't want to plunge with the mill. So we now have a super easy option here in our box here. Instead of auto plunge, I can now say do not plunge. And so it's going to have the exact same behavior, but it's not going to try and get into these cavities. So I know a lot of people are extracting the geometry on the part and using that as a boundary so that it doesn't try and go in those places. I've seen people, extract geometry the size of the stock and make them all air so that it'll break through and that kind of stuff. And all that kind of stuff is automatically handled with this new operation. So that's extremely nice, I think. The other thing you might be wondering here, I'll leave those activated. Does this work with volume mill? And yes, it does as well. So volume mill does it all in one operation. You see, it just goes around, and so we're saving a lot of time using volume mill in conjunction with this operation. The volume mill dialog box is a little bit different, so I'll show you where it is here. Plunge type, do not plunge. So really cool stuff. Let's real quick take a look at what this looks like on the machine. Enters from the side and comes outward. And we don't even have to worry about the cavities. And this is the volume mill here. Kind of scrapes away at the sides and goes inward here. Yeah, another simple improvement that I think everybody will like. Let's do a little bit of turning now. So we actually had elliptical turning in previous versions of GibbsCAM. For those of you who may not have attended those or don't remember, this is how we turn shapes that are, one, not necessarily a circular profile, and two, that might be off center, right? So if I get a top-down view, we can see that, this first part is regularly turnable. I don't know if that's a word. But then it kind of goes off center here. So this is what we had before we could do OD. And I'll just kind of show this on our Hyundai Wia to give you a little refresher here. All right, so there's our part, our stock rather. And it starts off as a generic turning operation for the flat part, but once it reaches a point where it's off center, it compensates using the 3 linear axes so that we can still turn it off center. Kind of looks like it's bouncing on the surface there. So this is really good. If you don't have, any live tooling to mill this, you don't want to take it off this and put it on a separate machine and do another setup and all that kind of work. This saves you a lot of time as well. So we've had that, but now in GibbsCAM 2023, we can now do ID work. And ID work was a little bit more difficult to develop because you run into clearance problems and all that kind of thing. So there is an extra step in making this operation where you need what they call a spine curve going down roughly the center. In this case, I just made a point here, I made a point here, and then connected them with a linear line. And I think that'll be good enough in most cases. But if you have some real clearance issues, you might want to make a more accurate spine curve. But let me show you how this looks on our machine. I'm going to switch it over to half mode so that we can see the ID, get a better view. So really cool stuff. Anybody who's already using elliptical turning, is going to love this as well. So, all right. The next one. Here we go. This next one is lathe drilling with a counter-rotating live tool. So this is for people who have live tooling. And so we've programmed this part. We got a ton of operations here. But really all I care about in this example is the centerline drilling, oddly enough. So if you're finding that your maximum spindle feed rate is not able to get to where you want it, so in this case I'm using my Hyundai Wia, which the main spindle maxes out at 4,500 RPM, which is pretty good, but let's say I had a machine that couldn't quite go as fast, and I wasn't able to reach the RPM that I needed for a particular centerline drilling. So in this case, we're maxing out our spindle feed rate here. But since we have live tooling, we can use live tooling to rotate the opposite way and increase our effective RPM here. So I'm maxing out my RPM here. We can select this now, tool spindle on, and this is how fast your tool is going to go in the opposite direction. So if I put 1500 here, it's adding the 4500 from my spindle and the 1500 from my live tooling. So now when I redo this, the toolpath actually doesn't change. It looks identical. Oops, didn't mean to do that. Now when I post this out, we can see that we have an additional 1500 RPM. So if anybody has live tooling and is cutting hard material, I think this is a pretty cool feature that we've added here. Okay. Next one I want to show you is just a general enhancement. This has to do with collision reporting. All right. So I have a volume mill operation here. And those of you who are familiar with volume mill knows that it goes very fast at times. So this is an inch depth of cut. I believe, it's aluminum, right? But I'm worried about, maybe my fixturing when I'm holding this down, or I'm worried about, it feeding too fast into my part, something like that. So now what we can do is go into OpSim, and we have, when I right click the toolbar here, go down to our settings, we have a new option here in collisions and program checks to alert me if I go above whatever IPM, right? So I'm going to leave it at 500 here, and it's going to flash the stock, beep, log to a display, and stop the animation when my toolpath goes over 500 IPM. You also have to turn on your collision checking here. And right away, it hits 500 already. You can tell because it says high speed clash here. If I keep hitting OK, it'll keep stepping forward. But you see how there's this light red. That light red is where it's going over 500 IPM. If I don't want to keep hitting OK, I can just press play here. And it'll log all the places where it went over 500 IPM and kind of map it out on my part as well. So if you're familiar with volume mill, it kind of makes these little slots here. And then once these slots are made, that's when it goes as fast as it can out of these slots. So we can kind of see all the walls here. It's going pretty fast. It's going fast around this boss. So just a good reporting tool, and you don't have to use it with volume mill. I just thought that it was a good example, but yeah, you can now have it tell you how fast you're going. The last two things I want to show you are 5-axis. I know a lot of people who have 5-axis love the 5-axis deburring, where you can kind of just click your part and it'll deburr, add fillets to all the edges throughout your part here. I'm sorry, I opened the wrong one here. Give me 1 second. Okay. All right. So how you use the 5-axis deburring is you select your part or at least two surfaces, and anywhere those surfaces intersect, it's going to try and add a fillet here, right? So this is something we had in GibbsCAM already. But you see there's a lot of lift up moves here. And you might get what they call a knit line here. So every time it's lifting up and stepping down and re-engaging here in the same location. So you can end up with like a line here on your finish, which is obviously not good. Let me demonstrate this in our machine sim. So it lifted up there, and I think we get one every step down here now. So we've made an improvement to this in the newest version of GibbsCAM here. All I have to do is open up my process and go to my Surface Pass tab, and we now have a checkbox here called Spiralize Closed Contours. And any closed contour, no matter what shape it is, it's going to spiralize it so that there's no lift ups here. So you see all these are going to go away when I hit redo. And so now we only have one time when it comes down and one time when it leaves. All right, so that is our enhancement to the 5-axis deburring. The last thing I want to show is custom approaches and retracts in 5-axis. So we actually already have like a million types of retracts and entries. So if I come over to my link tab here, if anybody's ever used 5-axis here, you know that we have a lot of different options. So not only do I have all these different types of approaches, lead ins, lead outs, but then I can customize them by using these dialog boxes down here as well. So we had, virtually unlimited control before, but the one thing we couldn't do is tell it where you're starting and stopping, right? And a lot of times, I want a vertical tangent arc, but it's hitting my fixturing. So how do I get around that? And so now we can add custom approaches and retracts. So custom approach, custom retract, and I'm going to get my thing in a good position here. So this is my approach. So I say add definition and say that I want to start, here, and add another point, start here. And not only can you add the specific points where you want it to go, but you can also tell it what the tool axis should be at each individual point, right? So at this point, not only do I want to go to this exact point, but I want it to go straight up and down in Z. So this is going to guarantee that at this point, it's going to be the tool axis is straight up. I can do the same thing on the other side here. Let me reposition. Okay, so I'm going to do the same thing on the way out. Okay, so now that I've added my points, I can hit redo. Watch what the entries and exits do. So now you see it's entering here, it's following this line. If your points are connected, it'll make sure to follow the curve that connects them. So if I had like a spline connecting these or something like that, my toolpath would come down to this point follow that spline to the next point. Whereas if they're individual points, it's just going to take the shortest path to get to the next point. So really now we truly have unlimited control with our 5-axis entries and exits. And I'll start by stepping down. So remember, I guaranteed that my tool axis would be straight up and down in Z on that first point. But then after that, I said, I kind of don't care after that point. So, and it can be kind of difficult to stop the simulation right where I wanted here. So bear with me. Oh, I forgot to turn on my points as well. We're getting close. I'm going to play it slowly. Hopefully we can catch these points on the way out. One more pass. So it happened pretty fast, but it did follow these points on the way out. So those are all the things that I picked to show you guys for this presentation. But like I said before, we actually have a lot more, maybe 5 times more. So we're going to be making YouTube videos and putting those online, and you guys should receive a link to that so you can watch those at a later time. But that's all I have for you. So I'm going to pass it back to Mike.
All right. Thanks, Michael. Great job. Great job. So one thing I'm going to do right now is I'm just going to check the chat. Don't you can leave you can still share. But see if there's any thing, and I don't see anything from the web attendees. So I'm going to throw it open to the live attendees here. Anyone have any questions, comments, or whatever on what they saw? Mike Pellegrim from Waltech does.
It's real intuitive as far as head,
right.
If you suppress those, that suppressive seems taking into consideration.
Yes. Yes, it's like they were never there. But now you can bring them back. So like Michael said, one thing that's always, like you pointed out, somewhat annoying is sometimes it's too smart for its own good, the rest milling. And so you say, well, I really don't, and you play games like you put it up front first so that it bypasses. Now you don't have to do that anymore, okay? Yeah, so you can do what-if scenarios and do it. So exactly what you're saying. It's like it's like they don't exist if you deactivate it, but that they're really still there if you want to, yeah, right? So does that answer that? All right. Anything else, guys? All right. Well, I think that's it, Michael. I think you're off the hook.